In this video, we are going to look at solving a system of linear equations by using the substitution method. Now, in order to substitute, you need to have a variable that is isolated by itself and it's equal to an expression. If we look at the two equations, x plus 3y equals 5 and 5x plus 4y equals 3, we see that there is no variable that is isolated. If we look at the lead coefficients of x, 3y, 5x, and 4y, I'm going to solve the first equation for x because there's no lead coefficient, which means I'm not going to need to divide and I'm not going to have any fractions. So if we solve this equation for x by subtracting 3y, we end up with the equation x equals negative 3y plus 5. Now that x is by itself, I can take the expression negative 3y plus 5 and substitute that in place of x. So we would have the equation 5 in place of the x. So we would have 5, and then in place of the x, we are going to put negative 3y plus 5, and then continue the rest of the second equation, plus 4y equals 3. And so if we distribute, we have negative 15y plus 25 plus 4y equals 3. Combining like terms, negative 11y plus 25 equals 3. If we subtract 25, negative 11y equals negative 22. And if we divide by negative 11, we see that y is equal to positive 2. So our y-coordinate of our ordered pair is positive 2. Now, in order to find the x-coordinate, we need to take our y value of 2 and substitute back into the first equation. So x equals negative 3 times 2 plus 5. We end up with x equals negative 6 plus 5. And so x turns out to be negative 1. So our ordered pair, or the solution to the two equations, is the point negative 1 comma 2. As a note, if you were to graph these two equations, we would end up with two lines that would intersect at the point negative 1, 2. Looking at the second example, we have the two equations 3x minus 3y equals 2, y equals x plus 2. We can see that y is already by itself, so we're going to take the expression x plus 2 and substitute in for y. So we have the equation 3x minus 3, and then in parentheses, in place of y, we're going to substitute x plus 2, and then continue the rest of our equation, equals 2. If we distribute, we have 3x minus 3x minus 6 equals 2. The 3x and the negative 3 cancel out, so we have the statement negative 6 equals 2. And this is a false statement, a non-true statement. So if you recall in past scenarios when solving equations that lead to a non-true statement in the end, we have a solution of no solution. If you were to graph these two lines on the coordinate plane, you would end up with a set of parallel lines that do not intersect. Taking a look at our third example, 9x plus 3y equals 12, y equals negative 3x plus 4. Again, we have y already by itself, so we can take the expression negative 3x plus 4 and substitute in for y. So if we write the equation 9x plus 3, and then in parentheses, substitute in negative 3x plus 4, and then continue the rest of our equation equals 12. If we distribute, 9x minus 9x plus 12 equals 12. The 9x and negative 9x will cancel out, so 12 is equal to 12, and this is a true statement. So as you can recall, in this scenario, since we're solving a system and on a graph these would be coinciding lines, keep in mind all real solutions and infinitely many solutions are not acceptable solutions. We would say that the solution are all of the points that satisfy the condition where you have an x and then the equation negative 3x plus 4, where you would have all of the points on the line y equals negative 3x plus 4 as your solutions. Thank you for watching.